Hey everybody, today we are working on number 30 in the spring 2019 Math MCAS release. We're going to do just this problem because it's a four-parter, so I like to break these up and just do one video on this. If you are doing this, hopefully you will have already taken it or tried it online. The link to the digital version of the test is found in the video description. There's also a link to a printable PDF, which is what this is. If you're one of my students, you should already have this packet. So the idea is you try the problem digitally, and then you follow along here and write down notes in this packet, and then you have a study guide going into the test. Okay? All right, let's go right into it. A student graphed triangle PQR on a coordinate plane as shown below. Okay, so here it is. The student reflected triangle PQR over the x-axis to create triangle EFG. What are the coordinates of vertex E? Show or explain to get your answer. Okay, so we're looking for the coordinates of this point here. Okay, let me zoom in a little more here. We're looking for the coordinates of point E. All right, and they tell us that this triangle is the image when you reflect triangle PQR over the x-axis. So let's go ahead and highlight the x-axis. So there's the x-axis, right? So we're going to reflect this. So it's going to be here, here, and 1, 2, 3, 4. 1, 2, 3, 4. I'm just counting the spaces from the line of reflection. Okay, that's all I'm doing. You could write down the coordinates of P, Q, and R and flip them by changing the sign of the Y value, but you don't need to do that. One little confusing thing is that they're not using P prime, Q prime, and R prime. They're just assigning brand new letters, which is a little confusing. But you have to just remember that they line up in the same order. So point P lines up with point E, so this would be point E. It's hard to see that. Q would be point F, so this is F, and R would be G. Okay, so we're looking for the coordinates of point E, which is right here. This would be -1, -1. Okay, pretty straightforward. Okay. If you were doing this, well, when you're doing this digitally, you wouldn't. Well, I guess if you have the dry erase marker, you could write right on your screen, which I think would be, in this case, would probably be pretty easy, honestly, or make it easier rather. All right, I'm going to be flipping back and forth here. Part B: a student performed a different single transformation on triangle PQR, and they created a new triangle called JKL. The coordinates of vertex K, which is this point here, are 4, 1. What could the single transformation of the student? What could be the single transformation that the student performed? Okay, so we know we're looking for the coordinates. We're looking for what happened to go from here to here. And they're giving us the coordinates of K. K matches up with Q because it's in the same order. It's the second letter. So what we're going to want is the coordinates for Q. So let's go back and look at Q. So Q is here. So it's 1, 2, 3, 4, 1. So it's -4, +1. So -4, +1 is Q, and it becomes K, which is +4, 1. So we could graph that. Let's graph 4, 1. So 4, 1's here, right? So you can kind of see what happened here, right? If you also remember your rule, you'll know that when the X value changes signs, that's a reflection over the Y-axis. Okay. Now, if you don't remember that rule, it's okay. What I would recommend is graphing this point, labeling this, what is it, K, right? And then you can kind of see, well, they're equidistant from the Y-axis, therefore that would be our our line of reflection. Okay, but it's a lot easier if you remember the rule. So we're going to say reflected over the Y-axis. Okay, let's try part C. Describe a single transformation the student can perform on triangle PQR so that its image, triangle UVW, is similar to, but not congruent to triangle PQR. All right, so similar but not congruent. Enter your answer. Okay, so here's what we're going to do. We have to remember there's 3 rigid transformations. Okay, there's translations. That's a shift. Translation, I can't spell today. Translations, that's a shift. There's rotations. That's a twist. And there are reflections. And that's a flip. Okay, those all preserve congruency. Those are going to keep the shape keep the two figures to be the same shape and same size. Now, there's another type of transformation that does not preserve congruency, and that's called a dilation. Okay, a dilation can be an enlargement or reduction. Okay. Now, basically, the number that we dilate from, the number we dilate with, if it's between 0 and 1, it's going to be a reduction or shrink. Okay. If it's larger, if the absolute value of it is larger than 1, it's going to be an enlargement, and if it's 1, it doesn't change the size at all. So we're going to change the size because we want it to be different sizes. Not congruent, but it will be similar. So we're going to say it's a dilation with a scale factor of 2. So basically what that means is we're doubling its size, okay, but keeping the same shape. All right, part D. What will the coordinates of vertex W be, or what will be the coordinates of vertex W after the student performs the transformation described in part C? Show or explain how you got your answer. So vertex W. So W matches up with R. So we're going to need R first. So point R is going to be, let's see, point R is here. So it's -4, +4. And we're applying a dilation. The scale factor of 2. So what that means is we're going to multiply these two values by 2, and that's going to give us point W. So -4 times 2 is -8, and 4 times 2 is +8, and that would be our coordinates. Okay, that's it. All right, so that's number 30. Hopefully that answers your questions on this one. The main thing is really, you're going to have to really be able to identify what points we're talking about here, right? So knowing that E matches up with P because the order of the letters, right? Same here, K and Q. And then W, what is it, this one? W and R, right? All right, so let me know if you have any questions, guys. Thanks for watching.